All right, we're live. Okay, so what I'm going to do here, we're going to talk about this Bellwork. I'm going to go through it kind of slow-ish so that you have something to look through, pause, do the stuff, whatever. So let's refresh what we're doing here. We're going to basically coast down a hill and see how far up we can go up the next hill before we have to start pedaling under our own power. So I gave you the mass here. Again, I didn't really have to, right? Mass doesn't matter. We've had some discussions about this. We've also had problems with this, that mass really you can plug in whatever you want. I gave it to you here just to prevent that confusion so that we have that. But keep in mind, you do not have to. You can pick your own mass if you want. All right, so it's a windy day. Wind is blowing at our back. It's going to help push us down the one hill. It's going to help push us up the next hill. So let's solve the problem together. I know these are two bad words. We'll talk about them later. I know. We'll get there. We'll get there. All right, so I'm going to just kind of redraw the thing. We've got a velocity at the top of this hill. What was it?
8.3 meters per second.
8.3. We've got some dip here. We're going to add some energy here. We're going to add some energy here. And then at some point, we're going to get to some elevation. We don't know what it is, where we finally run out of energy up the hill. What else are we given in the problem? What's our elevation here? What's our elevation down here? Bro. Meters, and again, this is our question mark. So, step one is complete. I drew a picture. Now, I know on the quiz yesterday I kind of included the picture on the thing, so you didn't really need to redraw it. Some of you did, but you really didn't have to, I guess. But then the next part, and I had this up for the test also, we had labeled this as A, this is B, and this is point C. So I'm going to do that same thing here. And then I'm going to list my things that I care about. And again, you don't have to do this, but I'm going to propose that this will help keep things straight. And on a question like this, part of the difficulty is there's a bunch of different numbers floating around. Kinetic energy, mechanical energy, potential energy, the height, the velocity, so on and so forth. Some of the difficulty of these problems is simply keeping all this stuff straight. And as soon as you start doing algebra and math and writing things down, and this number carries to this number, if you're not methodical and careful with where you put those numbers that you're generating, it can sometimes be difficult to know, where did I put this, where did this number go, whatever. So all I'm going to do with this chart is keep my stuff straight. That's all this chart is for. Is just like data collection, like in a lab or an activity that we do, you want to collect your data somewhere. That's all we're really doing with this. You're still going to have a spot on your paper, on your quiz, on your test where you're doing all the math, right? Writing down GPE equals MGH and plugging in some numbers. You're still going to have that to do somewhere. But I'm going to tell you, if you keep your data table together and keep it straight, it's going to make, I think, solving these problems that much easier. So now that we've got this set up, we've got to decide, what are we doing with H? And what do I mean by that? What do I mean? What do we have to decide?
Where H equals 0 is.
Okay, H equals 0. We've got to kind of decide what we're going to do with height, how we're going to keep a convention together. Now, in this case, how I've worded this problem, do we actually need an H equals 0? No, I've given you heights. Could you? Sure, yes. We could say this bottom, we could say H equals 0 here. And then this would become h equals the delta between these, so h equals 18 or whatever. You can do that. It is not going to make a difference in your eventual calculations. That'll make the numbers smaller, I guess, if I'm talking out loud, but whatever. You don't necessarily have to do that. Okay, so we're just going to use the heights that it's given us. So our height at A is 320. Our height at B is 302. And then what's our height at C? We don't know. That's actually what we're after in the question, right? Like this is what it's asking, is how high up can we go? Ultimately, we want to get there to where we can solve for whatever that number is going to be. So that's kind of our target. So what else do we know? What else can we fill out in this grid without doing any math? Okay, velocity today. How do I know that? It's given. It's given to us in the problem, right? 8.3 meters per second. What else do I know? Anything else we want to fill out in the thing? Velocity at C. What's that going to be? 0. And again, why? How do we know that? Well, it's given to us. It was in that picture. Yeah, so at max height, what is my velocity? 0. That's when I finally, I'm cruising up this hill. I start off really fast at the bottom. Eventually, I'm going to get to where I've got to start pedaling again. Ugh. Right? So here we go. Now that we've decided this, what can we start doing? Math. So again, you know your formulas for these, right? 1/2 mv squared. You've got mgh. You've got ke plus GPE. And we can start doing the actual algebra. So what's my kinetic energy at A? Oh yeah, we got to add in, what was our mass? What's our kinetic energy at A?
Once you get before that, like you're about before you.
Okay. Everybody agree with this? How did we get that?
We have the 70 HPC plug it all in.
So we just plug it in, right? We're just plugging that in. Again, this is going to be somewhere else on your page. Do your work somewhere. Do your calculation. What about MGH for this? It's our GPE. Big number?
Yeah, 22193.115.
We'll just trim it to 6 sig figs. Okay, is that? I know you probably want 8 or 12 or 17 sig figs. We'll just leave it alone at that. And then lastly, what can we do with the mechanical energy at our start point at A? 2, 2.
I gave you a flipped. I was giving you the mechanical energy.
Bro.
221.
So it's that. And then,
So there you're saying this one is different.
yeah, that one's 219520.
219520. Okay, so I got it now?
Yeah.
Okay, so I 100% agree. Again, if you picked h equals 0 at the bottom of the hill and did something else, your numbers are going to be a little bit different here. But trust, at the end of it, it's going to be fine. So let's go back to the question. So what do we need to do now? Do we have conservation of mechanical energy in this problem? No, why not?
Because we're adding wind.
We're adding some wind. Now, depending on what the problem states, sometimes we'll be on this perfect, ideal roller coaster. We'll ignore friction, we'll ignore air resistance, but today we're not. The wind is blowing in Iowa. What do we do with that number? Dash.
That's it. What I did is I put an arrow going from the line from A to B. That's a plus 22,100.
Where?
Like almost directly on the bottom line, right there, yes.
Okay, I think I like what you did there. So you're saying you did something like this, where you had plus 22,100 joules from here to here. I kind of like that. I like that. That's using the thing. So what do I then have to do? Add it to what number?
Mechanical.
The ME. All right, so what is that number?
2,444. 031.15.
244031?
Yeah.
I like that. Now, what could you do next?
I can do B and find the other stuff.
You could just skip that and just.
Oh, do we need all this stuff here? Could we find it?
Yes.
Yes, for sure. If you're just morbidly curious as to how fast you're ripping down that hill at the bottom, you can absolutely solve for that. You have your height, so you could find your GPE. You have your ME, so you can back into this. Yes, you can absolutely find that out, but do we need it? No, we really don't.
Because we can just do the exact same.
Yeah, so we're gonna do the dash method. And we're gonna say, well, we got wind again to 100 joules. So what is that gonna change again? We're adding some more energy, which technically isn't gonna be mechanical energy. That would be like total overall energy. But for the sake of our math, let's just do it this way. What,
266,131.
and finally, now what?
Then equal to you make that your GPE, you make that as velocity.
Yeah, so if our velocity is 0, what's our kinetic energy here? 0. Also 0. Not meters per second, joules. So where is all of this? At the very end, where did all of this energy go? Into potential energy, pushing us up the hill. And now what? What's our last step? Just some algebra, right? We know what our formula is. For GPE, we can extract out our H, which is what we've been looking for the whole time. And the number we get is?
387.94.
How many?
387.94.
388. We'll trim it to 3 sig figs for the sake of my sanity. 387.94, we're just going to go ahead and call that 388. Okay, so again, strategies for solving these problems. 1, draw your picture. 2, figure out what you're doing with height. 3, draw a grid. Start putting stuff in. Pick an A, B, and C if it's not given in the problem. Start plugging in what you know. And some of this is not necessarily going to be explicitly defined in the problem. You kind of have to understand, right? It might say starts at rest. Well, what does that mean? Okay, we have a 0 meters per second somewhere. We ride till we run out of speed. Okay, well that means at the end, our velocity is going to be 0, and so on and so forth. So some of this is extracting from the problem where you need to put in some bit of data. Questions? All right, nice job.